So it seems to me as though we need one last test. Now, one last test is the root test. Now, kind of like the ratio test, you're going to apply this when it looks like it's going to work out okay, like a problem's begging for the root test. And those problems are going to be things that have something to the nth power or something to the 2nth power, etc. And what you're going to do is you're going to take the nth root of your term, take a look at that limit as n approaches infinity, and kind of like the ratio test, if it's less than 1, then the series is convergent. If it's greater than 1, the series is divergent. And if it's equal to 1, ratio test tells us nothing. But it's all going to come down to, what's the size of that ratio? Is it greater than 1, less than 1, or equal to 1? So now obviously you don't want to apply this for every term, for every type of sequence. It's just things that look like they might simplify pretty nicely. So an example would be, let's see, we're at F now, I guess. So we'll do example F. And let's look at the series, the sum from n equals 2 to infinity of negative 2n over n plus 1 to the 5n power. So you've got something to some multiple of nth power. So that's kind of suggestive of a root test. And the nice thing is I don't have to calculate two things like we did with the ratio test. I'm just going to proceed to calculate the limit as n approaches infinity of the nth root of, I think I want the absolute value of that. Let's just take a look back here. Yeah, the absolute value. So I'm going to get rid of the negative 2 there in my term and just look at the limit, the absolute value of that. So it'd be 2n over n plus 1 to the 5n. It may help us in simplifying this if I rewrite this nth root using exponents, rational exponents. Limit as n approaches infinity of 2n.
Could you go back up a little bit? Just
2n over n plus 1 to the 5n raised to the 1 over nth power. Now, why did I do that? Well, I did that because those are going to cancel. And that's what I wanted to get to. So the limit as n approaches infinity of 2n over n plus 1 to the 5th power. Okay, well, what's going to happen with that? What's that limit going to be?
Is that 2? 2.
Oh, God.
Okay.
2 to the 5th?
Yeah, it's going to be 2 to the 5th power. Yeah, so what I was going to say is you can take a look at the limit as n approaches infinity of 2n over n plus 1 and raise that to the 5th power, so you're going to get 2 to the 5th. And the unfortunate thing, if you're cheering for convergence, is that's greater than 1. What's that tell us? Someone. What's going to happen with the series?
It's divergent.
Yeah, it's going to diverge.
Where did the negative go?
Well, part of
On
the
the
root
2.
test, you're going to take the absolute value of that term.
Okay.
So I just chucked the negative. I'm like, you know what? I'm taking the absolute value here. So I just ignored the negative.
Right. And then how are you just like square rooting it? Is that not like changing the a sub n?
Oh, well, this is applying the ratio test. right? So the ratio test says, take a look at the nth
Oh,
root of a sub n.
okay.
So that's where that was from.
Oh, so you're just plugging it in. I see.
Yeah, so I plugged in the term into the nth root. The nth root I rewrote as, something to the 1 over nth power because I saw that convenient cancellation there.
Right.
Okay. So in hindsight, looking at this, you can take a look at these terms. You get an n and n plus 1. So these terms are either going to 2 or negative 2, but they're certainly not going to 0. So it's not a surprise that this limit didn't converge, but it's nice to be able to show it. And we did it with the root test. Let's do one more example like this. So sum from n equals 1 to infinity of 3n plus 2 over 4n plus 1, the nth power. Any guesses if this is going to converge or diverge? Well, for my, got a guess can converge. What guides your thoughts that way?
Because the nth power is 1, so it'd be the same powers. So I guess 3 over 4, but there's an n in outside the parentheses. So
okay. So if this was like 3/4 to the n, then that'd be a geometric series. Oops, let me do it like that. 3/4 n. Now the 2 and the 1, they're not going to mean anything when the values of n get really, really large. They're going to be so small, they're not going to see it. So this is going to be really close to 3n over 4n. I can't keep on blocking that n. And 3n over 4n is just like 3 over 4. So it looks like a convergent geometric series for large values of n. It's not, but that's what it looks like. So you might be thinking, okay, it's probably going to converge. But either way, let's use the root test. So the root test is going to look at the limit as n approaches infinity of the nth root of 3n plus 2 over 4n plus 1 to the nth power. Now, kind of like our last example, those n's are going to cancel. And I'm left with the limit as n approaches infinity of 3n plus 2 over 4n plus 1. And that limit is 3/4. So it converges. Converges by the root test. I can't say that the root test gets used all that often by me. It seems like there has to be a special problem that you'd have to set up to use the root test, but they are out there. And for the ones that it works for, it's nice and convenient. So how are we looking on that one? Okay. Let's see. So one of the more famous mathematicians in history is a guy by the name of Srinivasa Ramanujan. And here's a picture of him. He's an amazing mathematician. I think he died when he was like 32 years old. He was born in the late 1800s, lived till 1920. He was totally self-taught. And if you wanted to see a decent movie, a fictionalized version of his life, I think it's reasonably accurate. I've never seen it myself, but I've heard good reviews about it. It's called The Man Who Knew Infinity. It probably gets that name because he came up with all kinds of amazing series. So here's just a few examples that I've pulled out. 10 minus pi squared is this sum. Wow, 1 over k cubed times k plus 1 cubed. Pretty wild. The next one, it's pretty crazy because it involves some amazing things in math. You got pi here, but another famous constant called phi here, and that's equal to this mess. It's an alternating series. Look at that. You got the square of a factorial, another factorial here, another term like that there. This one's kind of fun. But let me show you a couple of the really bizarre ones. This one. How on earth you would come up with this, I don't know. And what's really cool and dare I say sexy about this one is that it's got a double factorial. This number here is bigger than your calculator can hold when n equals 2. It's just crazy big. Because if you put in a 2 here, that'd be 8 minus 1 is 7. 7 factorial is 5,040. But then you got to take a factorial again. And just so you know, the largest number that you can take a factorial of on your calculator is 69, because 70 factorial is going to be too big. Error, overflow. But if I think it's 69 factorial works. So anyways, it's just amazing because he's doing this without computers and stuff. And you got 99 to the 4n plus 2 power. And somehow multiplying by that, the square root of 8 gives me 1 over pi. Wow. How about a brilliant one for the square root of pi times e over 2, this continued fraction? Or a nice quick approximation that pi is about 99 squared over 2206 divided by or times the square root of 2. There's a cool story about Ramanujan and it's called the taxi cab number. He was being visited in the hospital by his professor, and allegedly not knowing what to say, the professor found out, oh, well, the taxi cab I had drove over here and had a really boring number. It was 1,729. Ramanujan says, no. That's a really cool number because it's the smallest number that can be represented as the sum of 2 cubes in 2 separate ways. And he just knew that off the top of his head. Just amazing. So anyways, Ramanujan. Check them out if you can. Do you want one more? Let's take a look at one last one with series. And I just want you to think about this one. So, example, where are we at? We're at H now. Sum from, let's do k for a change. K equals 1 to infinity of 6 times k e to the negative k. Well, this part has a power, but this one doesn't. And, boy, I just don't think that's going to work out too good with the root series, with the root test. Because if you start taking a look at the roots, the root is not going to simplify to anything really nice. You're going to be stuck with it. So the root test doesn't work for everything. That's fine. I mean, you can rewrite it. You can take the 6 out in front. K equals 1 to infinity. And maybe it's helpful to write this as k over e to the k. Can anyone think of a different test that I can use that could help me show the convergence or divergence of that series? How about another? Go ahead.
The integral test?
The integral test, yeah, it actually might work. Yeah, the integral test would
This is one of
probably
the
work.
on our homework.
Yeah, I think the integral test here would work. I actually had a different test in mind, but the integral test would work. And when you take your exam from me, some of these problems are going to have more than one right answer, and it's just going to be extra work for me to look through and make sure that your test will work, and I'll do that, no problem. But the test I guess I was thinking of would be the ratio test. But you're right. I think the integral test would work out pretty good here. Well, let's just practice the ratio test just for giggles. So a sub n would equal, call it n over e to the n, a sub n plus 1, n plus 1 over e to the n plus 1. And now let's simplify a sub n plus 1 over a sub n. So this e to the n plus 1 divided by this is going to be like multiplying by the reciprocal. So e to the n, and then what? Well, we're going to get some cancellation. We can cancel out all but one of the e's here. So let me rewrite this as, well, let's do it like this. E to the n times e, n plus 1 over n. Those cancel. So I'm left with 1 over e times n plus 1 over n. I don't really need the absolute value on this. That's part of the limit though. Limit as n approaches infinity. I can bring the 1 over e term out front. One over e, n to infinity, n plus 1 over n. This limit is 1, and that's okay. I left with 1 over e times 1, which is 1 over e. Because that's less than 1, therefore the series converges. By the ratio test. Yay.
Professor.
Yes, please.
So we do not have to say this series converges like absolutely, right?
You know, generally not. This series does converge absolutely because, you know, if you take the absolute value of the term, it's not going to change. They're always going to be positive. So this does converge absolutely. Yeah, but unless it's an alternating series, I'm probably not going to look for you to say converges absolutely. The only time I'm really going to be looking for you to say it converges absolutely is if it's an alternating series, because otherwise it's just going to converge or diverge. And so like your homework in section 11.5, it's just, does it converge or diverge? It's in 11.6 that they actually start looking for you to say it converges absolutely or converges conditionally. So, but yeah, to answer your question, typically we're not going to worry about that.
Thank you.
Thank you. Okay, that's it for the root test. Any other follow-up questions on the root test or on Ramanujan? He had a unique quote about how he came up with all his series. He came up with like books full, tons of them. And it says, Ramanujan said that the gods left drops of vivid blood in his dreams after he saw the blood scrolls containing complicated maths unfolded before him. Now, the way I heard it was that the blood was on a wall, and when the blood drained down, it revealed all these formulas, and in the morning he woke up and wrote down as many as he could remember. But what's true is that he came up with some really astounding ones. Very interesting.
So that's kind of similar to the way Tesla figured out AC current or AC electrical systems.
Oh yeah.
Because he said he had dreams from God or like visions or that he couldn't
Really?
really make sense of. Yeah, because when he went to Edison in like the early, I don't even know what it was, early 1900s or late 1890s, Edison was completely baffled by AC.
Yeah, Edison didn't like AC, and in fact, contracted to build an electrical chair out of DC current just to show how
Yeah.
dangerous it was. Yeah, no, it's exactly what it did. Edison was not always the nicest of guys, I guess.
He was more of a businessman.
Yeah. So, yeah, Tesla died poor, if I remember right.
Yeah, he kind of got screwed by Edison, but
Yeah, he did. Okay, cool little bit of history there. Thank you so much. Let's call it a day on this section. We're not done though, so don't go anywhere.